Fellow developers, welcome to our channel. Today, we have something special in store for you. If you're a Java enthusiast or looking to level up your Java skills, you're in the right place because, today, we're diving into the world of Java tricks that every developer should know. You know, mastering Java isn't just about writing code that works. It's about writing code that's efficient, elegant, and takes full advantage of the language's capabilities. In this video, we're going to explore 10 must-know tricks that will not only make your code cleaner, but also make you a more effective Java developer. But before we dive into the world of Java magic, make sure to hit that subscribe button below and ring the notification bell so you won't miss any of our future coding adventures. And hey, if you find any of these tricks particularly helpful, don't forget to give us a thumbs up. It really helps out the channel. Alright, without further ado, let's jump into it. In the ever-evolving landscape of programming languages, Java stands tall as a testament to its enduring relevance and significance. Its impact on the programming world is far-reaching, shaping the development of enterprise applications, web-based solutions, and a plethora of other digital products. At the heart of Java's popularity lies its versatility and cross-platform compatibility. Unlike many languages that are tethered to specific operating systems, Java's write once, run anywhere principle allows developers to craft code that seamlessly executes on a wide range of platforms, from Windows and Linux to Mac and mobile devices. This portability has been instrumental in Java's widespread adoption, particularly in the realm of enterprise applications, where the ability to maintain code consistency across diverse environments is paramount. Java's object-oriented programming (OOP) paradigm further enhances its appeal. OOP promotes modularity, code reusability, and maintainability, making it an ideal choice for developing large, complex software projects. By encapsulating data and behavior within distinct objects, Java promotes a structured and organized approach to programming, reducing development time and minimizing errors. The language's robust security features are another cornerstone of its success. Java's built-in memory management, exception handling, and access control mechanisms provide a solid foundation for secure software development. This inherent security is crucial in enterprise environments, where protecting sensitive data and safeguarding system integrity are paramount concerns. Java's extensive ecosystem of libraries, frameworks, and tools further cements its position as a frontrunner in the programming world. A wealth of open-source libraries and frameworks, such as Spring and Hibernate, provide developers with readily available solutions for common programming tasks. This vast array of tools streamlines software development, allowing developers to focus on core functionality rather than reinventing the wheel. Java's versatility, object-oriented nature, robust security features, and extensive ecosystem have cemented its place as a foundational language in the programming world. Its continued relevance across diverse domains, from enterprise applications to mobile app development, underscores its enduring impact on the software industry. The enhanced for loop, also known as the for-each loop, is a syntactic sugar introduced in Java to simplify the process of iterating through collections, arrays, lists, sets, etc., or any other iterable objects. It provides a more concise and readable way to traverse elements without the need for explicit indexing or manual control of the loop variable. Here's the basic structure of the enhanced for loop. Starting for loop with open bracket, then writing element type, and then name of the variable, collection, bracket close, starting curly bracket, writing your code, and then finally closing the curly brackets. How it simplifies iterating through collections. Readability. The enhanced for loop abstracts away the details of indexing and iteration, making the code more readable and less prone to off-by-one errors. Developers can focus on the logic inside the loop rather than managing loop variables and indices. No need for index variables. Unlike traditional for loops where you might need an index variable and explicit indexing, the enhanced for loop eliminates the need for an index variable altogether. This reduces the chances of mistakes related to manual index management. Automated iteration. The loop automatically iterates over each element in the collection. It simplifies the iteration process by handling the start and end conditions for you. Compact syntax. The enhanced for loop is more concise compared to traditional for loops. It requires fewer lines of code, contributing to a cleaner and more maintainable codebase.
Let's look at an example using an array. In this example, both loops achieve the same result of printing each element in the num array. However, the enhanced for loop provides a more straightforward and less error-prone way of expressing the iteration logic. Lambda expressions were introduced in Java 8 as a way to provide a more functional programming style. They're essentially a concise way to express instances of single-method interfaces, also known as functional interfaces, without the need for anonymous class syntax. Traditionally, if you wanted to implement a simple interface with a single method, you might use an anonymous class. Let's say we have an interface math function with a method function in A, in B that we want to implement. Inside the main math class, we create an instance of the math function interface using an anonymous class. This anonymous class implements the operate method to perform addition return A plus B, and multiplication return A asterisk B. Now enter lambda expressions. They provide a more concise syntax for achieving the same result. Let's rewrite the previous example using a lambda expression. That's it. The lambda expression in A minus 1bo greater than a plus b effectively replaces the entire anonymous class. The parameters are specified on the left side of the arrow, greater than, and the body of the method is on the right side, similarly for multiplication. The optional class in Java was introduced in Java 8 to provide a more expressive and safer way to handle situations where a value might be absent or nullable. It is designed to reduce the risk of null pointer extension and encourages developers to explicitly handle the absence of a value. Let's discuss how the optional class helps in handling null values more effectively. Scenario 1, dealing with a non-null value. Here, we create a user object user1 with a non-null name. The code string username1 equals user1.getName. Works fine in this case because user1 is not null. However, if user1 were null, attempting to call getName directly on a null object would lead to a null pointer extension. Scenario 2, dealing with a null value. In this scenario, we create a user object user2 with a null name. Attempting to call getName directly on a null object user2 will result in a null pointer extension. This kind of scenario can lead to unexpected crashes in your application. Let's contrast this with the optional example. In the optional example, the use of optional prevents null pointer extension by providing a clear and expressive way to handle both present and absent values. The map function is used to transform the value if present, and orals provides a default value if the value is absent. This makes the code more robust and less error-prone when dealing with null values. The Streams API in Java is part of the java.util.stream package and was introduced in Java 8. It provides a powerful and expressive way to process collections of objects. The Streams API allows you to express complex data manipulations in a concise and functional style, making your code more readable and maintainable. Let's explore the key features of the Streams API and demonstrate how it simplifies working with collections using filter, map, and reduce operations. Let's say we have a list of integers and we want to perform various operations on them using the Streams API. This code uses the filter intermediate operation to filter out even numbers from the list. This code uses the map intermediate operation to square each number in the list. This code uses the reduce terminal operation to calculate the sum of all the numbers in the list. These examples demonstrate how the Streams API allows you to perform operations on collections in a concise and expressive manner, making your code more readable and often more efficient. The declarative style of the Streams API makes it easier to understand the intent of your code, and it encourages functional programming practices. Resource management is a critical aspect of programming, and it involves efficiently handling and releasing resources such as file handles, network connections, database connections, and more. In Java, managing resources is crucial to avoid resource leaks, ensure proper cleanup, and improve the overall reliability and efficiency of your code. Let's discuss some of them. Preventing resource leaks. Not properly managing resources can lead to resource leaks, where resources are not released or closed after use. This can result in reduced system performance and, in some cases, exhaustion of system resources. Ensuring data integrity. Proper resource management is essential for maintaining data integrity. For example, failing to close a file or a database connection after use may lead to data corruption or loss. Avoiding security vulnerabilities. Resource leaks can also be exploited as security vulnerabilities. For instance, leaving a network connection open might expose the system to unauthorized access or attacks. Improving code robustness. Proper resource management contributes to the overall robustness of your code. It helps prevent unexpected errors and ensures that your application behaves predictably, especially in long-running applications. Java introduced the try with resources statement in Java 7 to simplify the process of managing resources. It ensures that each resource is closed at the end of the statement, regardless of whether the try block completes normally or an exception is thrown. In this example, the buffered reader is a resource that reads text from a character input stream. It is created within the parentheses following the try keyword. With try with resources, there's no need for an explicit finally block to close the resource. The buffered reader will be automatically closed when the try block is exited, whether it completes normally or an exception is thrown. By leveraging the try with resources statement, Java developers can write cleaner, more maintainable code while ensuring proper resource management. The var keyword was introduced in Java 10 as part of the local variable type inference feature. It allows you to declare local variables without explicitly specifying their data types, letting the compiler infer the type based on the assigned value. The primary benefits of using var include improved code readability, reduced redundancy, and enhanced conciseness. Traditionally, a variable named names is declared with the type explicitly specified as list string. It's initialized with a new ArrayList string, and a variable named fruits is declared and initialized with a list string greater than containing some fruit names. Then, a traditional enhanced for loop is used to iterate through the list and print each element. But now, the var keyword is employed to declare a variable named names. The type is inferred by the compiler based on the assigned value new ArrayList string. Similarly, the var keyword is used to declare a variable named fruits. Again, the type is inferred from the assigned value arrays, a list apple, banana, orange. The enhanced for loop also uses var to iterate through the list. While var can enhance code readability, it's essential to use it judiciously. It's most effective when the assigned value clearly indicates the type. Avoid excessive use in cases where the type may not be immediately obvious, as it could lead to decreased code clarity. In Java 10 and later, the local variable type inference feature introduced with the var keyword has been extended to lambda expressions. This means that you can use var to declare the parameters of a lambda expression when the type can be inferred from the context. This enhancement aims to improve code flexibility, conciseness, and readability, especially in situations where the type information is obvious. Here, the lambda parameter word is declared using var within the map operation of the stream API. The type is inferred based on the type of elements in the words list, making the code more concise. The completable future class in Java is a powerful tool for handling asynchronous programming and concurrent execution of tasks. It is part of the java.util.concurrent package and provides a way to express and compose asynchronous computations. Completable future simplifies the handling of asynchronous tasks by allowing you to chain actions, combine multiple asynchronous operations, and handle exceptional scenarios. Introduction to completable future. Asynchronous programming. Asynchronous programming involves executing tasks concurrently, allowing your program to perform non-blocking operations and efficiently utilize resources. Completable future features. Completable future supports composition of multiple asynchronous operations. It provides a fluent API for chaining actions and combining results. Exceptional handling is integrated, making it easy to deal with errors in asynchronous computations. In this example, completable future.supply async is used to asynchronously supply a result hello. Finally, async is used to chain a function that transforms the result hello to hello world. Async is used to consume the final result by printing it to the console. The multi-catch feature, introduced in Java 7, allows you to catch multiple exceptions in a single catch block. This makes exception handling cleaner and more concise, especially when the catch blocks perform similar actions for different types of exceptions. Before Java 7, if you needed to catch multiple types of exceptions and handle them in the same way, you would have to write separate catch blocks for each exception type. With multi-catch, you can catch multiple exceptions in a single catch block, making the code more concise. JourneyStart is a redevil print loop REPL tool introduced in Java 9 that allows developers to interactively experiment with Java code. It provides a lightweight and interactive environment for quickly testing and prototyping Java code snippets without the need for a full-fledged development environment or a separate compilation step. Key features of JourneyStart. Interactive environment. JourneyStart provides an interactive shell where you can type and execute Java code directly. Immediate feedback. Code snippets are executed immediately and results are displayed in real time. Variable persistence. Variables and methods declared in one command are available for subsequent commands, enabling incremental development. Expression evaluation. JourneyStart evaluates expressions and statements, allowing you to see the results instantly. Type JourneyStart and use it. Hope these will help. If you found any of these tricks particularly helpful, or if you have your favorite Java trick that we didn't cover, let me know in the comments below. I love hearing from you, and I'm always up for a good coding discussion. Now, before you go, don't forget to hit that like button if you enjoyed this video and found it valuable. And, of course, if you haven't already, subscribe to our channel for more in-depth discussions and all things